everyone. So today we are going to shift from 34.1 to 34.2, and we're going to start focusing on the volume of prisms today. Now, volume is a figure that is measuring the amount of space that a figure encloses, and it's going to have three dimensions because we're taking up all that space. So our units from here on out are going to be cubed when we talk about volume. Now, in order to find the volume of a prism, it is going to be the area of your base times the height. Now, a reminder, the area of your base is never just a singular one-side dimension. It's always going to be the area of something. So whether that be a rectangle, a triangle, some kind of formula you're going to need. And basically, to find the overall area, you need to follow 4 simple steps. First is picture what your base is. Draw the picture of the base, and you're going to find the area of said base. Well, from here, you need to then identify the distance between your two bases, aka the height of your segment, and finally, you will plug it back into the formula. So for the practice problems here, the first two are going to be rectangular prisms. Now, what you're going to notice with the rectangular prisms is officially all of the sides are rectangles. So when you identify your base, it's not necessarily as big a deal of which side you choose as your base. You just need to identify it so that you can correctly identify your height. So for instance, we can identify this rectangle right here as our base. And notice we have 7 and 12 are the side lengths of that. So the area, base times height or length times width, however you see it, is just going to be 7 times 12, which is a total of 84 square feet. Okay. Now from here, our other base would be, I'm going to sketch this in over here, and the height again is the distance between these two figures. So our height then is this 15. So in order to find the overall volume, area of the base times the height, well, we calculated the area of the base to be 84, calculated the height there to be 15, and 84 times 15 is 1,260 cubic feet. Now from here, when we look at the second example, again, it does not matter where you choose your base to be for these rectangular prisms, you just have to stay consistent. So in this case, if we choose 4 and 3 to be the side lengths of our base, okay, 4 times 3, our total area of the base is 12 feet squared. And the height then between them, the distance between them, is 12 for an overall volume of 12 times 12, or 144 cubic feet. Now, just to show you that this is going to work either way you choose it for these rectangular prisms, notice if we choose instead for the area of the base to be here. So we have in our area of the base here a side length of 12 with our rectangle, and then notice the other side, if we keep this consistent, is going to be 3. Well, the area of the base then would be 12 times 3, or 36. The height then between these two bases is this 4. So the height is 4, and the overall volume then would be that area of the base times the height, which also came out to be 144. So you have a little bit of flexibility when it comes to our rectangular prism problems. Now, this is very different, though, when we start talking about prisms with bases other than rectangles, because you really need to focus in on what is the shape of my base and how do I find the area of it. So in this case, we have a triangle as our base. Now, notice the length of that is 10, and then they're telling us the height here is 12. So in order to find the area of this triangle, it's 1/2 the base of the triangle times the height of the triangle. So half of 10 times 12 is 60 square units. Okay, now the height then is going to be, again, of the overall prism, is the distance between your two bases. So this 25 is going to represent our height when we want to calculate the volume. So the overall volume of this prism, area of the base times the height, aka 60 times 25, which is 1500 cubic centimeters. Now the last example on this page is also another triangular prism. Now again, what this means for us is that our base here is a triangle, and in this case they're telling us it's a right triangle with sides of 6 and 8, and also notice they did officially give us that hypotenuse there was 10, they just didn't write it up top here, they wrote it on the bottom. Okay, now in order to find the area of a right triangle, which a lot of times we look at like this, we know that it is base 1/2 base times height, and the base and the height of a right triangle are going to be its legs, which are in this case 6 and 8. Oh, that's terrible. 6 and 8. Write that. So half of 6 times 8 is 24 square inches. And then the height between these two, no matter where you're looking at on here, here's our height distance between our bases, is going to be 4 inches. So our overall volume, again, area of the base times the height, so 24 times 4, 96 cubic inches. Okay, so biggest battle here is definitely making sure that we have our area of the base computed correctly. Now on the back, if you flip your page over, we have the volume of a prism is what we are looking for. But, the volume of the prism with an equilateral triangular base is 187.2. So they're giving us that volume. Notice they gave us the cubic units, so that's kind of our indicator. They also gave us the area of that triangular base is 23.4. So they gave us that area. What we're looking for here is the height of our prism. So we need to kind of work backwards here. We know that the formula for the volume of a prism is the area of the base times the height. What we need to do then is plug in what they gave us. They gave us that volume. They gave us that area of the base. The problem here is the overall height, and we need to isolate that h by itself to get our final answer. Well, in order to do that, if we are multiplying these two, to undo that multiplication, we need to divide both sides by 23.4. So 187.2 divided by 23.4, we get a height of 8 units. Height is 8 centimeters. Notice our units are not squared here or cubed because we're just talking about the height in centimeters. Okay. Now our last example is a little bit of a doozy, so bear with me on this one. Okay. Notice they are giving us in this particular problem a couple things. They're giving us the surface area and they want us to find the volume. Okay, so that's our overall thing, but they gave us the overall surface area. Now notice here, the reason we can't just also jump and compute the volume is while we're given some of the parameters of this rectangular prism, we're not given the height. So that's where this surface area is going to come in, is it is going to allow us to solve for the height. Now, if you look on the formula sheet that you have here, and we go back to surface area, a reminder, the surface area, one of the formulas we have for that is that it's the perimeter of the base times the height plus 2 times the area of the base. So what we're going to have to do here is look at a couple things. First off, we are going to look at the perimeter of the base. Now, if we choose here to make the base this piece here, okay, notice this 12 is going to be the side length on both pieces. So the perimeter here of this is going to be 25 plus 12 plus 25 plus 12, adding up all four sides of our base to get a perimeter of 74 feet. Okay, now the height, again, we don't know at the moment to help us find the surface area on that, right? But we also can compute the area of this base by taking 25 times 12 to get our area of the base, which is going to be 300 square feet. Okay. Now, surface area, again, from our formula on the sheet is the perimeter of the base times the height plus 2 times the area of the base. Well, let's start plugging in what they gave us. They gave us that surface area was 822. And then we computed over here that the perimeter is 74. So we can plug that in. And then the height is, well, we don't know. It's a question mark, so we're just going to keep calling that h. And then the area of the base, we also computed over here to be 300. So 2 times 300. So we can start solving now for h by simplifying some math. So we have 822 equals 74h plus 2 times 300, which is 600. And then we're able to start isolating for h. So we're going to subtract away the 600 from both sides. So 822 minus 600 is 222. And then finally, to get the height by itself, we need to divide by 74. So our height here ends up being 222 divided by 74, which is, excuse me, just 3. Now, we're not done, all right, because if we look back at the question, they're asking us again for the volume. So now we have all the pieces we need, though, because the volume is found by taking the area of the base, which was 300, times that height we just calculated, and that gives us a final answer of 900 cubic feet. It's quite the doozy on that one. Okay, we had to use all the pieces. All right, good luck with the practice. It's nice and spaced out for you. And any questions, let your teacher know. Thanks, everybody.